This is homework 15 with Nick Losi and Caleb Unger, and we are going to address the index problems of 6.3, 6.4, and 6.5. Now, one of the reasons I'm going to start with 6.5 is because the amount of time it takes to compile and run all of the code. And so basically what I'm going to show you first is the hedging procedure. I just basically initialized all the variables and then incorporated each of the equations that we're going to use, including our d, our delta, and our c. And then we just went through the algorithm as listed out in the book based off of the variables that it gave us, calculating a new d and a delta, and again comparing the criteria to see if x is greater than that initial price paid for. And so once we figure this out, basically the methodology is to store the final cost into a mu sub I and then find the mean cost and the standard deviation of that cost, as you can see on the screen. In the end, we will plot a histogram, and it should migrate over to be centered right above 20 actually. And as we can see, once I come down here, basically in order to do all these iterations, I just initialized up top the number of hedges basically that we were going to utilize. So in the final problem, we see that it is fairly centered as it migrates over to 20, and it is no longer a stair step, but very, very centered, very normal looking. And I can show you the first one if we run that really quick to show you that it has migrated as proof. Let's see here. And as you can see, it has gradually migrated and become centered as we have increased the hedges that we consider. This is the first scenario where there's only one hedge. And then up at the top, we simulated basically just geometric, actually Black-Scholes formula for the European call. This is the European call formula, taking into account the differential equation that we talked about and the error formula that's built into MATLAB based off of the parameters that were given. And we do get the same exact answer as you can see in the window below. And then if we move on to the last problem, or the middle one that I'm choosing to do last, 6.4, I'll go ahead and evaluate that. Basically what we get again is the same answer that we receive in the book, which you can see on the screen right here. And that's using Monte Carlo as well to simulate the call option for the European call. Thank you for watching this video with Caleb Unger and Nick Losi. I hope you find it helpful when doing the next homework for European call and Brownian motion. Thank you.